So earlier we discussed how a Lorentz force acts on a conducting ladder network if you move a magnet on top of the ladder. And we saw that how the current is induced, and that induced current, how the voltage is induced, which will run a current, and that current, when you're moving the magnet, is going to produce Lorentz force, because then you have a current carrying conductor which is being acted upon by a moving magnetic field. So we saw that how it will start moving in the same direction as in which your magnet is moving. Now the rotor in induction motor basically is what, if you take this ladder and then you bend it upon itself. So basically you bend it from this side to this side. What you're going to get is something what we call something like this, what we call a squirrel cage. This is like a squirrel cage. So basically if you open it and basically cut it from here, let's say, and then open it and flatten it, it's going to become a conducting ladder network. And when you bend it upon itself, then it is going to become a rotating, a circular object, what we call a squirrel cage. And this is used as the rotor inside your induction motor. So how does induction motor work? That squirrel cage rotor is basically placed in the center of your three-phase stator. So we place that squirrel cage rotor right over here. As you can see, this circle, this is squirrel cage rotor. So now when you have your three-phase magnetic field, you have the magnetic field or magnetic flux, which is the rotating magnetic flux with the speed of ns. When the rotor inside is acted upon this magnetic field, then what is going to happen? Basically, each bar of the rotor is going to induce a voltage, like we discussed earlier, that each bar of your ladder network is going to induce voltage. So in the same way, each bar of this rotor, where it's gonna, let me see, right here, each bar of this rotor is going to induce the voltage. And when the voltage will be induced in each bar, then of course, since it is shorted out at the end, what's going to happen, it is going to start running currents, as we saw earlier in the ladder network. And when it will start running current in the shorted network of bars, then Lorentz force is going to be applied on that, which will start moving this rotor, and since it is free to move, which will start moving this rotor in the same direction in which the magnetic flux is moving. Remember, earlier we saw that it was moving in the same direction, the ladder network was moving in the same direction as your moving magnet. So the same thing is going to happen here. This squirrel cage is going to start moving in the same direction, either clockwise or counterclockwise, based on in which direction your magnetic flux is moving. So that's a very basic but a very important phenomena of rotating an object under the influence of a moving magnetic field. And that sets actually the induction motor apart from what we have learned earlier. Remember what we have learned earlier in DC motor case, that we had to supply the current to the armature in order for the armature to move. Here we are not supplying current to the rotating part, rather the voltage is induced and the current is produced by that induced voltage. So here we are using Faraday's law actually. When we are inducing the voltage, there is no physical connection of your power supply to the rotating part of the motor or rotor of the motor. So that's makes it different from what we have learned so far. So this is how the induction motor works. There's a really good video of the working of induction motor by Learn Engineering on YouTube. I encourage you to look at that video, and it is explained in detail how induction motor works, but this is basically the basic idea of how the motor works. You have a three-phase system, or three phases connected to the stator, which produce a three-phase rotating magnetic field. And when that three-phase rotating magnetic field is acted upon this rotor, it induces the voltage in each bar of the rotor, which runs a current because it is shorted out at the ends, which runs current. And when the current is running, of course, and you have the rotating magnetic field, Faraday's law is the Lorentz force is going to be applied, and your rotor is going to start moving if it is free to move. So that's how the three-phase induction motor works. Let's see what is next. So this is, I explained, you can read in detail, everything is given here. Three-phase induction motor. Now the speed, there is a speed with which the three-phase induction motor, the rotor, will actually be moving, and that speed with respect to the speed of the rotating magnetic field is measured in terms of slip. So ns minus n, ns, remember, is synchronous speed, the speed with which your magnetic flux is moving, and n is the speed of the rotor. So the difference between this speed, so n is the actual speed of the rotor, so difference between these speed is called slip speed. And when you take the ratio of the slip speed with respect to the synchronous speed, this parameter is called slip, and this is used very commonly. So now remember, as we discussed earlier, the speed of the rotating the rotor, speed of the rotor will never become equal to the speed of the rotating magnetic field, that is synchronous speed. Why? Because if it will become equal, then your rotor relative speed with respect to the synchronous speed is going to become 0. ns minus n is going to become 0, and as soon as ns minus n becomes 0, what's going to happen? The voltage will not be induced anymore because your relative velocity is going to become 0. So voltage is not going to be induced anymore. That means, of course, there is no current, there is no Lorentz force. So your rotor will never catch up with the speed of your rotating magnetic field. It will always be less than the speed of the rotating magnetic field. When there is no load connected to the induction motor, both speeds will be very close to each other, and it will be around 0.1%. Slip will be around 0.1% or so. But as you put load on the induction motor, then of course it will slow down a little bit, and your slip is going to increase. So when you put load on the motor, how it works, it is given over here. There was what will happen. So no, I hope you can read it. The basic idea over here was to teach how basically the induction motor works using a rotating magnetic field. Rest of it is pretty straightforward, pretty easy to read, so make sure you read it. I'm not going to make a video of all these topics, but these topics are pretty straightforward and pretty self-explanatory. So make sure to read these topics, and if there will be a question, then of course you can ask questions either through email, or we can have a video conference. So make sure to read rest of the topics, and I'm going to create some examples and then post them online.